G'day all, it's Brendan here, back from RGK. Look, I just thought I'd touch base with you. We've had a number of questions and queries in regards to the word power in terms of the power assist, so and how that works, and also what it means. So quite often you'll see power, watts, torque, and it all gets pretty confusing. And demystifying that is some of the purpose of this video, and also in regards to how that relates and works with the battery. And also the wheel size that you're looking for as well. So I'll try not to get too technical with it. Some of it is going to be a little bit technical, so do apologise for that. And as always, if you do get stuck or you just want to know more information, just drop us an email or give me a call. More than happy to have a chat with you and talk anything through or give you more information. Okay, so here we go. Brace yourself. What I'll do is I'll break it down into three sections. So the first one will be the motor itself, then the battery, and then the third one will be the wheel. Okay. So good luck, hold on, sit down, here we go. Righty-ho, so the motor. So the motor of power assist relates to the amount of available energy or power or watts or torque that the bike has available. So ideally what you're looking for is a bike that is able enough to obviously propel yourself up and down hills and round flats and do it in a level that's comfortable. Okay. Now the main thing is you've got to be aware of is the higher watts that you'll see advertised on a pamphlet will be, for example, 2,000 watts or 1,000 watts or 1,500 watts. What that means is that technically that's the maximum capacity of that motor. So it doesn't mean that you're always going to be sitting at that. It's like driving a car. You don't always drive with the throttle down on the ground, but when you have that ability to have the extra power available, what that does is it gives you a steady sort of delivery of that power and makes it easier to maintain the speed. What that mainly does too is you want ideally your motor running between sort of 60 to 70% of its total capacity, of its absolute maximum capacity. And the way that is done is obviously through the electronics. Now with Tri-Ride, obviously we can customize those, and we do customize those for whether it be people, different people, individuals, kids, older people, all range of different things, and also heavier users as well. So the when you get a motor that's running at above sort of 70 or 80% of the actual capacity of that battery, what happens is that you start to wear out the battery. You start to wear out the motor, sorry. Okay, so because it's working harder, and then that also affects the battery. So obviously when the motor's working harder, it needs to draw more power from or energy from the battery. Same as a car. If you floor the accelerator all the time, you're going to drink a lot of petrol, and you're going to spend a lot of time at the petrol station to fill up. So with the motor of the power assist, what you're looking for is something that is going to provide a constant and a steady sort of a pull, if you like, when you're starting off. Now, usually what you find is when a motor is a smaller motor, what it has to do is when you start accelerating, it has to basically essentially push a lot of power through the motor to get you moving. Now, what that does is it obviously creates a lot of wheel spin, and you end up losing a lot of control and power and that sort of stuff. Now, some of that can be managed through the size of the wheel that you've got, the size of the wheel you put on it, whether 12 or 14 or 16 or even the new ones in terms of 20. But the ability to maintain traction and also the safety side of that is critical, and I'll cover that in the next section of the wheels. But the when you deliver the power, so even a standard gradient of sort of 3 or 4%, just a normal hill, the motor to hold a speed of around sort of walking speed, 6 to 8 Ks, you're looking between 250 and about 400 watts is that the motor will need to maintain grip and will maintain that momentum. So that's obviously allowing for a little bit of slippage, but also different surfaces and that sort of stuff as well. So whether it's grass or concrete or asphalt or gravel or whatever it is. So as you can see, so it's the way that that's delivered is the critical part. So being able to customize that and being able to make sure that the power is delivered in a linear way. So you're not using the whole 2,000 or 1,000 or whatever it is watts. What you are trying to do is you're trying to maximize the way that that is delivered. So customizing the delivery of that is going to be critical to making sure that you get a smooth, gradual and controlled acceleration or deceleration for sometimes as well. The biggest thing that you quite often see is the words watts or power. Now, watts, power and torque are all essentially the same thing. So what you're wanting is torque. In a power assist, it's all about torque. Power can be a bit misleading in the sense that people think you're going to go fast and you're going to be flying off the side of a road. It's not about speed. It's certainly not about speed. What you're looking for is torque. Torque is a pulling power, and then you want the pulling power because you obviously got to maintain momentum. Now, when you're on a power assist device, any power assist device for that matter, momentum is critical. So momentum will allow you to get over things through surfaces that have less grip, long wet grass, for example. The more you can maintain that momentum, the more effective the device will be. Now, whatever device it is, I haven't specifically talked about tri-ride because I want to make sure that it's open for all devices. It's all about the way that power is delivered and maintaining that smooth progression across the surface. So now the more power you have available, or the more torque that the motor has, what that does is it provides a more linear and more controlled acceleration and maintenance of that speed. Okay, so the main thing you've got to look out for is a bike that has, in summary, you're looking for a bike that has a power reserve that is commensurate to the obviously the weight you are, the surfaces you're wanting to travel, and the way that the power is delivered, so they can control how that power is delivered. Because if you need to accelerate hard to get the bike moving, it's going to suck a lot of energy from the battery, and the wheel's just going to wheel spin. You're going to lose control, and then you could end up in a situation where you can't steer, because when you start slipping, as in a car, you can't. You basically lose your ability to steer. Okay, so that's one of the main things you got to look out for from a power assistant, especially in the motor side of it. Now, moving into the battery side of it, now the batteries obviously go hand in hand with the actual motor itself. So the battery is critical to obviously how effective it is to get from the stored energy in the battery to the actual motor. Now, they come in a range of sizes and a range of capacities. The main thing that you've got to look out for firstly is that the motor and the battery is built for purpose. So if you have a low voltage battery, what happens, and you're a heavier guy or a heavy user in terms of you're going through grass, so you're putting a lot of torque on the motor, because you've got a lot of drag happening on your chair and on the wheel itself. So you need to increase the amount of power. So the amount of draw that's coming out of the battery is going to increase. So having a battery that is mated to it properly, that facilitates that, is going to be critical. Normally what you'll see with power assist, the voltage of the battery is either 36 or 48 in the main, and then the amperage, which is the other one. So that is how capable the battery is to withstand a constant draw. So anything above sort of 10 to 12 is your ideal, especially when you're a heavier user, or you're going across a lot of terrain that is quite torque intensive or power, or that sort of power intensive. So like, for example, long grass, where you're in the chair, you're going to be dragging you through the thing. You'll be dragging through the grass or the wet mud and that sort of stuff. So those are the main things to think about. Obviously, you've got some of the weight with it as well that comes into it. Obviously, the high capacity battery, usually the higher weight will be as well, which isn't a bad thing, because you can use it for traction, especially when it sits over the front wheel. The other thing as well is charge times for these normally is about 3.5 hours from dead flat, that sort of thing, which isn't too much of an issue, but it's something to consider. The third part of this is the wheel. So the wheel is obviously the bit that actually puts the torque to the ground. So the wider tyre you can have is the better. So whether it's a 12-inch or a 14 or a 16 or a 20-inch, the wider tyre you have got is going to be critical to making sure that you get the best out of your power assist device. And then obviously, the closer you can mount that drive wheel to the centre of mass, i.e. where you're sitting, the more traction you will get. The further the wheel is away from you, the less weight that's over the wheel, and what that means is less traction, but also your ability to maneuver the device as well. So when the wheel's a long way out in front of you, obviously getting around things, maneuvering, turning tight when you need to is going to be trickier. So the main rule of thumb with the wheel size, from what I found and from my own sort of research and investigation, 12-inch wheels are great for urban environments, general sort of asphalt, walking trails, light gravel, cut grass, harder sand. They're okay on that to a point. But looking at a tyre that's sort of 2 inches wide is ideal. And then the next one up from that is your 14-inch tyre. Again, you want something that's about between more than 2 inches is ideal in width, because obviously the surface area, you're going to get a lot more traction and you get a lot more control of the bike as well. 14-inch wheel is good for everything that the 12-inch can do, but obviously there's a bit more off-road capability in terms of the grass and off-road and that sort of stuff. And also the size of the wheel, what that does is it translates the torque of the motor more effectively, because you can cover more ground. You've got a bigger rolling diameter, so covering stuff that's a little bit rough, I guess, you're not going to get that wheel hopping, which is you've probably all experienced it. You're going to get wheel hopping, which means that you're going to end up losing traction. You don't want the wheel to hop, you want the wheel to stay in contact with the ground. So I hope that was of some interest, and I hope that gave you some insight in terms of what's available, and demystifying some of that stuff around power and torque and watts and all that sort of thing. Like I said, any questions, do give us a call. More than happy to have a chat to you or explain some things further. I've tried to keep this relatively short because otherwise people just get a bit get switched off by it. So give us a call if you need. You can either call myself, Brendan, or Scott. He's the big, tall, lanky one that doesn't do a lot, but he's available if you need as well. And we're more than happy to have a chat with you and cover any questions you may have. Other than that, have a great day, and we will no doubt see you on the road. Cheers, bye.